Hey everyone, we will start shortly. Thank you for coming. And I posted the paper that we will be discussing in the chat, so feel free to check it out. And we will start in 4 to 5 minutes. Hi LT, how are you? Oh yeah, and feel free to share the room with friends that you think are interested in rejuvenation, Alzheimer's. That's what this is about today. It's a really interesting feature. Hi Walter,
Hello.
it worked. Everything is fine.
Okay.
Thank you.
So I'm not gonna see any slides, though, right? I don't see anything.
I'm putting up the slides right now. I shared in the chat the paper, so if people
Okay.
want to check it out in the meantime. And there it is. You see it?
Okay.
Yeah, it should work.
Yeah, I see it now. So
Perfect.
whenever I go down, people are gonna see what I see or not? So
No,
like
so it's
right
really
now, you see the slides moving or not?
no. So it's really helpful if you
Oh, so
say,
I had
"Are
to
we moving
describe
to
the
the next?"
slide, right? So,
Yeah, exactly. We're moving to the next slide, and if you see that it also counts the slide, so you can also say which slide number, because
yeah.
if you
Okay.
click on
All
it,
right. Good. Yeah. So I'll do that. Yeah.
yeah,
Yeah.
perfect.
Okay.
Thank you so much for doing this. We really appreciate it.
Sure. A little complicated to tell you the truth, but
Sorry. Well, you know, there's other space, like Clubhouse was the first audio social media app, and there's Twitter Spaces where one can do this, and on Reddit they have it. But for this audio social media, the Clubhouse still works the best, I think. And the recordings are good because when you come and listen to the recording on Clubhouse, the link to the presentation and also the links in the chat is still active. So it's almost the same experience, just you cannot ask questions. So that's why we kind of like it. And then Clubhouse is also, I think, the only one where you get the raw audio file. So we usually upload it then later on for people on YouTube and Spotify, just because there's never a time where everyone can come. It's impossible because some people are in Asia, some people are, Katie's in Australia, then other people are in Europe, a lot of people are in Europe. So there's never a time for everyone. So we kind of think that then the recording is like a better experience on this app than on the others. So that's
yeah.
why.
Yeah. Okay.
Yeah, and this app started really during COVID when everything was shut down. It started as like conversation, like people used to just have conversations here.
Yeah. No problem.
Yeah, I'll hope you'll enjoy it. So it's an interactive way of basically doing a small podcast recording, kind of. That's good.
Yeah.
Yeah, we'll start in around 1 minute, everyone. So feel free to share with friends. It's an open room, everyone can come. And yeah, everyone is welcome. It's about rejuvenation. Who doesn't want to live healthier longer? It should be. Um, yeah. So right. So Walter, you also have a company, right?
Yes. Yes. I founded a company. Yeah.
Yeah, that's great. That's wonderful. I saw it. I can share also the company link in the chat if you would like. Or would you like, while we just talk a little bit before, to have the
You can
website?
mention the company. I usually the university doesn't like it if I talk about the company, but you could say if you want to say,
Yeah,
you can say it. You know, it's okay.
here we can do whatever we want.
Yeah.
Nobody's
No, no,
paying
I
us.
know until the university finds out, and then
Ah,
it's
they
like,
don't like it.
oh,
Yeah.
yeah.
Oh, sorry. Yeah, then it's up to you. I can.
No,
I
no, you
can.
can mention it. You can mention it. I don't. You were gonna mention it, so mention it, and I'll just,
Yeah.
I can answer questions about it. I just cannot make it part of my presentation.
Okay. Then we will mention it. It's interesting.
Yeah, and you have a company, right? I saw that.
Yes. Yeah. Yeah, but I'm non-tenure track, so
So they don't come after you. Huh?
no. I right now I really don't get really paid. I'm still there officially, but I'm transitioning more and more away
Towards the
for
company.
a while. Yeah. Um, let's see
And
if
that-
it works.
and how's the company doing? I saw the psychology assessment, or
That's what I started with, and then I also started a little bit of like I have one drug target and one repurposing of two repurposing of drug patents pending.
I see.
Also, it started
Okay.
with that to finance the other research I wanted to do. That was the plan, and that's what's
Yeah, yeah.
happening.
Okay, good.
Yeah, and then I also consult for companies. Um, so yeah, a lot of work, and I have 3 kids. But anyways, oh, Katie's also here. Hi, Katie. Hi, Joyce. Hi, Denise. Meet Walter. We are about to start. Perfect
Hi.
timing.
Hi, I'm really excited about having Professor Longo here. I've read his book and I'm a fan.
Oh
Oh,
wow,
thanks. Yeah.
that's great. I'm always happy when out of this rooms like longer collaboration or something starts. Sometimes this happens. I'm always happy when that happens. Okay, I think we can start. So, welcome everyone to Science Society. I know people will still keep coming in. So, yeah, feel free to share the room with friends, and we'll go from there. So, before we start, I want to introduce you to the guest speaker today. And first of all, Walter, thank you for going through the trouble, making the account, coming here. I'm going back and forth to get this to work. It worked out, so thank you. We really
Oh,
appreciate
you're
it.
welcome.
And yeah, so Walter Longo, he's a professor of gerontology and biological sciences. He's a Edna Jones Chair in gerontology, and he did his bachelor at the University of North Texas and then his PhD at UCLA, and he did his postdoctoral training at USC. And his research is mostly focused on cell biology, regulation of aging, and multiple stress resistant systems. And he uses yeast and mammals as models, and he works also on Alzheimer's disease, cancer, and diabetes. Um, and he is also the director of the USC Longevity Institute, and he also has a company that he founded, Prolon Fast, and I pinned the information about the company, his company, on top of the room. I will switch that once Walter starts with the presentation. I will switch it to the slides and put the link to the company in the chat. So welcome, Walter. And we
Oh, thanks.
usually, yeah, and usually we start with a short kind of introduction interview, if that's okay with you.
Sure.
So, how do you did you start? Like, when did it start that you were interested in following the path of becoming a scientist? Was this something like a childhood dream? Was it maybe a class you took or a book you read or something that happened that you kind of wanted to become a scientist? Thank you.
Yeah, actually, no, I was a musician, and then they asked me to direct a marching band, and I didn't want to do that. So, but I always wanted to study aging for some reason, and so in my second year in college, as soon as I sort of was pushed away from the music program, um, I went to biochemistry, and I just thought chemistry and biology would have been the right combination to study aging and longevity, and that's all I've ever done since then, which is when I was 19 years old. Yeah.
That's so interesting. I feel, do you think a lot of scientists were also musicians or still have the passion for music? I feel like when I ask this question, it's more than any other, art or, passion people have. Is, I feel like music is the most prevalent. Do you think that's true? I don't know.
I think there are a lot of musicians in science. So yeah, there's probably some the personality that is drawn towards science is probably also drawn to music and arts in general. And yeah, so that's good. That's probably a good background to have. The arts background to go into science. Um, if not, if for no other reason, because it sort of makes you think different, right? So, and it's good to always start with new ideas rather than maybe just expanding on old ideas. You know?
Yeah, I agree. Maybe it's the creativity part. Yeah, that's important, and that you learn with music. And yeah, so you kind of answered already that, how you then went to choose the field you're in right now. But is there maybe like some background story about this specific project? Was it, or was it always really easy for you, your ideas, for example, to get funding for the very creative ideas or groundbreaking ideas, or was it hard? Or yeah, is there any story around the behind the curtains for this for the presentation you're giving today?
Yeah, no. At the beginning, I mean, I chose all the wrong things, right? So I chose aging, and this was the early '90s, and nobody studied aging in the early '90s, and at UCLA, it was sort of viewed as a weird science. And then and then I chose. I started working with yeast, so microorganisms, and so which was another thing that lots of people looked down upon because it's just viewed as irrelevant to human aging and longevity. And then I picked starvation, right? So not only microorganisms, but starving microorganisms, which people thought it was more even boring than microorganisms, right? So it was all the wrong moves. But maybe because of that sort of musician or artist type of background, I didn't care. And especially I came from the rock scene, and in the rock scene the idea was just play what you think you should play, right? Don't worry too much about what's fashionable out there. Yeah, so I think that that allowed me to combine all these things, and luckily the sort of the world turned towards aging and turned towards the genetics of aging and turned towards fasting in a way that we couldn't have predicted. But so I think that yeah, those were all good choices. Yeah.
Yes, I agree. You were way ahead of the curve. That's that's so important also to then, yeah, be successful. And apparently you were you were very persistent, so that's probably another feature that is important. Um, so I'm glad things worked out, because it's really important work, I think, to have like a good quality of life also later in life. And so yeah, thank you for keeping the path, although nobody else cared, because now we can like humanity can benefit from it. So that's really wonderful. Thank you.
Sure.
And yeah, so the presentation for everyone is pinned on top of the room. Please click on it to follow along the presentation. And Walter, the stage is yours. Thank you.
Yeah. Okay. Thanks, Katarina. So I'll just announce the slide number. So I'll go from slide one, my title slide, to slide number two. And in slide number two is something that Matt Campbell, a colleague of mine, sent me a few months ago, and basically is showing the risk factors for smoking, alcohol, obesity, for cancer, heart disease, Alzheimer's disease. And then if you go to slide three, you see how these risk factors almost disappear when they're compared to 30 years of aging. Right? So I think that back a long time ago, when a bunch of us decided that we were going to look at the genetics of aging, that was probably a good idea because the power of aging on so many different diseases and functions, right? So is so clear and massive. So if you go to slide four, then I always, I'm in the School of Gerontology at USC, and that's one of the oldest, probably the oldest in the world, dedicated to aging research. But I always thought I'm more interested in youth than I'm interested in the mechanisms of how organisms get old, right? So I came up with a new word, which is juventology, right? So which is the study of youth, instead of the study of getting old, gerontology. And then another term that I have in the slide is health span, the study of how long can we stay healthy. I mean, we always hear about centenarians and people that make it to record longevity, but does it really matter if you spend, as most Americans, 30, 40, 50 years or more on multiple drugs, with many drugs with multiple chronic diseases? So how do we get there? And one of the pillars that I base my work on is centenarians, right? So Madame Calmont in France still holds a record longevity, over 122 years of age, and so journalists and everybody actually likes to see stories like this. Like, she smoked until 117. She did not have a good diet, and so they basically use examples like Madame Calmont to make a point that maybe all these nutritional interventions are not that important. But it turns out that uh, in centenarians, um, many of the centenarians we follow, for example, Emma Morano, who I followed for years, had six brothers and sisters. All of them made it to over the age of 90, and so we know from many of the centenarians that they often have genetic advantages. So Madame Calmont, and many others can probably afford to do things that the great majority of people in the world cannot afford, like smoking, for example, or smoking and a bad diet. So clearly, we know that these are going to make your life shorter or much shorter. And so the slide number six is the title for the longevity diet. And then if you go to seven, I just want to say a few words about proteins and animal proteins in the diet. And so if you look at it, where it says GH, IGF-1, taurusis kinase, SSK, these are the genes that we and others have identified to be at the center of acceleration of aging. And it happens to be proteins, and particularly the amino acids in animal protein, that activate these aging accelerating genes. And so we, if you go to slide number 8, we looked at the U.S. CDC database and asked the question, what happens to people that have a low protein diet before the age of 65 versus a high protein diet before the age of 65. And it turns out that the overall mortality risk is almost twice as much in those that have a high protein diet, and the cancer mortality risk is 4 times higher in those that have a high protein diet. But this is not true for those that are 70, 80, 90 years old. And here you're already starting to see some complexity, and people like simple stories, but in fact, this is just the beginning of personalization of diet, and so we now think there's probably 4 or 5 different stages of life where maybe where people should have 4 or 5 different type of diets. It doesn't mean that you're going to change your diet completely, but some tweaking of the diet seems to be very important to stay healthy longer. So if you go to slide, and that was slide number 9. So if you go to slide number 10, now I talk about the longevity diet, and of course I'm not going to discuss all the reasons why we get to this diet, but this longevity diet is my book on the right. This longevity diet is mostly plant-based, vegan plus fish, maybe 2 or 3 times a week, low protein until age 65, 70, moderate protein after, high levels of legume, whole grains, vegetable, healthy fats, and high nourishment, eating what's called time restricted eating within 12 hours a day, not much longer, not much shorter. So I say 8 a.m. to 8 p.m. And if you're overweight, my suggestion is being eat probably breakfast and lunch, or breakfast and dinner, and then have a small snack for lunch or dinner instead of a major meal. And this is just if you're overweight or obese, not if you're normal weight. And then, what we pioneered is the periodic medically supervised, well, maybe not medically, but certainly, supervised by a dietitian at least, fasting mimicking diets once every 1 to 6 months. So we just finished multiple clinical trials on diabetes. It's very effective in causing drug reduction if done once a month, but we believe that the benefits will also occur if it was done less than once a month. Okay, so slide 11. This is not our study, a study by a group in Norway looking at life expectancy and nutrition, and looking at millions of people in Europe, China, the United States, and basically we were happy to see, this just came out 6 months ago, we were happy to see that in fact we got it right. And so the legumes, the whole grains, and the nuts come on top as those associated with the most life expectancy extension. And so compared to a Western diet, having the right longevity diet like nutrition, starting at age 20 is associated with 11 to 13 years of life expectancy increase. And if it start at age 60, still 8 to 9 years of life expectancy increase. So these are remarkable effects. And we think that if you combine it with all the other things that I just listed, maybe the potential is in the 15 to 20 years of life expectancy extension. Okay, slide 12. So what about people that don't want to change their diet? And so I'm not going to show it, but we did a study where we gave mice a very bad high fat, high calorie diet, and then we give them this low calorie, low sugar, low protein, high fat, plant based 5 days a month diet, and then the rest of the time we let them eat this bad diet. And just 5 days a month of this fasting mimicking diet was able, and this is slide 12, was able to reverse all the bad effects of this high calorie, high fat diet. And now this is not to advertise having a bad diet, but understanding that, as we saw for smoking, right? Even after it was clear that smoking kills you, half of the people or so continue to smoke, right? So this is a reality, no matter how bad the habit or the the lifestyle is. Okay, so then the Alzheimer part, slide 13. So we finally, after about 10 years of working on this, and a lot of people collaborating with us. We looked at, we published on the use of this fasting mimicking diet I just described in two different mouse models for Alzheimer's disease, plus we showed the initial clinical data for the first 30 patients that enrolled in a clinical trial of mild cognitive impairment and Alzheimer's disease. And this is Priya Rangan and Fleur Lobo were the first authors of this paper. Okay, so without going into the details, this is slide 14. And this is showing you, some of the things that we do, the testing that we do. These mazes that the mice have to figure out, where the hole is so they can hide in it. And in the slide 15, again, without going to the details, the idea is that the mice now that they're receiving, that they have all these mutations that are causing early onset Alzheimer's disease, and they have cognitive decline because of it. If we start the fasting mimicking diet, cognitively they do a lot better. They're able to remember things better, be quicker in learning, and use the context that surrounds them to make a decision on where to go. In slide 16, and now we're starting to see this. Recently, a reviewer of one of my grants said, does this FMD does everything? He of course was making fun of it, or he was trying to downplay it. But why does it do so many things, right? And probably, and in this case, in slide 16, I'm showing the effects on this beta amyloid that is accumulated in the brain. If you look on the left where it says E4 FAD control, these are just the mice that have the mutation that cause cognitive decline. And on the right is the same mice, but now treated with the fasting mimicking diet. See, these dark spots are much lower, and this is the beta amyloid, this peptide, this junk that accumulates in the brain and is believed by many to be responsible, or at least partly responsible, for the dementia in people. And so this goes down, and so does and this is in different type of mice. We see the same effect, and we see also the decrease of something called tau, phosphorylated tau. And so so now this fasting mimicking diet is able to improve cognition, reduce this junk in the brain. And if you go to slide 18, you see some of the what I just said. The fasting mimicking diet cycle is able to block A beta and improve cognitive impairment. So slide 19, and now we see that it's also causing neural stem cells to be turned on in the areas of the brain involved in cognition. And so and then slide 20, or slide 20 is just summarizing this. So the FMD reducing A beta, increasing the proliferating neural stem cells, so this type of cells that can give rise to new neurons. And then slide 21, now we're seeing also inflammation being reduced. This is a marker for microglia in this Alzheimer mice, and you see microglia is now lower, so it's less inflammatory cells after cycles of the fasting mimicking diet. And in slide 22 is just a summary of that. See the FMD reducing A beta, reducing inflammation, increasing stem cells, reducing the microglia toxicity, and also the production of reactive oxygen species by the microglia. So why does it do all these things? And we believe, and we have published lots of paper indicating that maybe starvation condition and refeeding condition together represent the two opportunities. Opportunity number one was get rid of junk, right? So uh, pre-cancer cells, cancer cells, autoimmune cells, cells that are hyper-inflammatory. So we know that, for example, during development, the body is very, very good at eliminating damaged cells, right? And making sure that only the good ones go and are used to form an embryo and then cause the development of that embryo. So it would make a lot of sense that the body, even in an adult or in an old individual, can go through and look for junk and eliminate the junk. And in fact, more than that, it doesn't only eliminate it, it uses it as food, right? So now a cell or a cellular component can be eaten up uh, and used as fuel, right? So, and in the shrinking process, so, but to do that, you have to be shrinking, right? You can't be maintaining a normal diet. There's not enough calories to do that. So you're shrinking because you have no food coming from the outside, and so you're using the food on the inside, right? So then when the food comes back around, you have to re-expand, and we know this. We know this also from human studies where Ansel Keys actually did this back in the 50s and 60s, and people undergo semi-starvations. They shrink, and the heart, for example, can reach 41% smaller size compared to before the starvation, and then within about 20 weeks that heart and all the organs re-expand. And so now we have lots of evidence suggesting that in these re-expansion moments or periods, now these embryonic development pathways are turned back on. So now, why not? The body is using, and we know this for sure in the mice. We still don't know if the same is true for people, but we suspect it is, right? So the body is using the same program that it was used to generate the embryo and the organs in the first place to re-expand these organs. So now slide 23, clinical trial, slide 24. This is just showing you the clinical trial on mild cognitive impaired patients and early Alzheimer patient in Italy, and now almost complete. The 40 patient enrollment has been completed, and now there's only a few that have to finish the fasting mimicking diet cycles. Surprisingly, it's feasible even for very old patients like these ones, and most patients, but not all, could complete the cycles of the fasting mimicking diet, and these are monthly cycles. So it's looking promising, and especially because it does not require the patients to change their diet. And then slide 25, this is the human fasting mimicking diet. And so we've now done lots of trials. I mentioned the diabetes trial earlier, but these are the fasting mimicking diet trials. And 5-day fasting mimicking diet, low calorie, low protein, low sugar, high fats, all plant based. And slide 26, you see the effects on fasting glucose. Now it's has these differential effects, right? If you have normal, the patients that have normal fasting glucose, they stay there, and those were pre-diabetic, they had a much larger drop, and most of them moved back to the normal state. Slide 27, IGF-1. This is one of the markers for aging and age-related diseases, including cancer. There's a drop in those they started with a normal level of IGF-1, but there's a much larger drop in those that were at risk for cancer after 3 cycles of the fasting mimicking diet. And C-reactive protein, so systemic inflammation, same. Nothing happens in those that have normal. This is slide 28. Nothing happens in those that have normal CRP, but those that are at risk, have high CRP, they have a much larger drop. Slide 29, same for cholesterol. Again, this differential effect, normal and cholesterol above 200, a much larger effect. And this is the summary, which is with chronological age, as the year go by, basically the biological age, so the status of the system, the system gets older biologically, and the disease risk, as I mentioned in my first slides, goes way up. And the everyday longevity diet plus the fasting mimicking diet um, can reduce the risk or incidence of age-related diseases, including Alzheimer. Now, keep in mind, I just mentioned, fasting glucose, C-reactive protein, but both inflammation and diabetes are major risk factors for Alzheimer. And so diabetics, now we know they have about 75% increase in the chance of developing Alzheimer. And so I think we need to start looking at cognitive decline and dementia as not just brain disorders, but as systemic disorders that have a major aging component and a major metabolic component. And so to treat them, I think we need to, yes, of course, the drugs, the brain-specific drugs are very good. Potentially, they haven't succeeded yet, but eventually we will have some. But I think that the effects on the system are as important, if not more important. And keep in mind that if we slow down aging by 5 years, we will cut Alzheimer by 50%, right? So just a 5 year postponement of the aging process will have a tremendous effect on Alzheimer, surprisingly, very little effort I think has been put into treating aging also for cognition and cognitive decline. And then just I already thanked the Fleur Lobo and Priya Rangan. They did most of the work on Alzheimer, and also my colleagues in Italy, Professor Odetti and Nencioni, and others that did the clinical trial, and then Morgan Levine worked on the protein study. So that's it. Thank you.
Yeah, thank you so much, Walter, for this really wonderful presentation and for this really interesting work. It's yeah, again, such an honor having you here, and thank you so much for sharing this.
Oh,
And
you're welcome.
yeah, everyone, please that have a question. I know Joyce is a big fan, she said, so please, Joyce, go ahead, ask your question. Thank you.
Yes, I'm absolutely a big fan, and I recommend everyone to get his book. You do such a great job writing. You tell it so clearly, and I love your focus on so many different types of evidence, and I also love the fact that you're doing like what I plan to do, and you're donating your share of the company's profits to charity and
Yeah.
research.
Well, thank you.
That's
Thank you.
yeah, yeah, I love that. And I I have this very long story of recovering from chronic fatigue syndrome that I got in my 20s. And I became, completely disabled. And I basically became sensitive to everything that I ate. And so it was a very
Hmm.
long journey. But eventually I figured out how to overcome my food sensitivities, and it was using heart rate data because there was a researcher from decades ago who discovered that there were heart rate effects of food sensitivity
Huh.
reactions. Yeah.
Interesting.
And I was going to say, I have a feeling, and this could be tested, and I hope to help test it someday, and I hope maybe we can collaborate, that the fasting mimicking diet, in addition to what you're discussing, it also reduces your sensitivities just simply by avoiding for a period of time. Because I, at a certain point, figured out that even the things that I didn't react to as much, I would become sensitive to over time. And if I took a break from them, it could kind of reset the system.
Yeah.
Um,
Yeah, probably. Yeah. I mean, certainly that's a component. I agree with you. And in fact, there was a paper years ago where they looked at rheumatoid arthritis, and they basically put people on a fasting, water only fasting, and then a Mediterranean diet, and at least for a while they improved, right? So yeah, it is possible that part of the effect is just taking a break, but also we published actually a paper on IBD, inflammatory bowel disease, and showed that there's a lot of probably inflammatory components, and anti-inflammatory components. So this FMD is affecting microbiota, is affecting the immune system, and so I think altogether the absence of the antigen, if you will, plus the effects on the immune system and on the microbiota altogether are probably contributing to making people And now we have three clinical trials on IBD, two at Stanford and one I think the University of Miami. And so hopefully at some point we will have more clinical data on this.
Yes, great. Thank you. Yeah, and actually, even though I would kind of like to do the FMD, I'm purposefully not doing it because I want to prove that I can get better without taking that kind of break. But anyway, I think it also may be worth looking into people who maybe don't do benefit as much, and maybe they're not getting enough of a break of the from the right, antigens. And also, you might want to look into this heart rate as an indicator because lower resting heart rate is associated with benefits in terms of all-cause mortality and various conditions. And you might find that their resting heart rate is lowered after they do one of the FMD sessions. And
Probably, yeah.
and
Yeah.
you might even find that my company is coming out with an app that you can use to detect reactions to your heart rate reactions to foods while you're eating them, because
Hmm.
some foods will cause it to go up while you're eating it and then go back down again after you finish chewing. And with now things like the Apple Watch, you can see that very easily, and then you can
Interesting.
yeah, so maybe I can get in touch with you in the back channel because that would be
Sure. Let
very
me send me some papers if there are papers on this.
great. Yeah, I hope we can connect. Yeah, thanks.
Thank you.
Yeah, thank you so much for Dr. Roshanak. Did you want? Yeah, go ahead.
Yeah, thank you so much, Katerina, and thank you, Dr. Longo, for this wonderful talk. And I'm just wondering, based on what you're saying, Joyce, and speaking to this, do you have any data on effects of this on heart rate variability?
No, not we haven't. I mean, we measure heart rate in the clinical trials, but I don't remember anything sticking out. Uh, but we don't do much during. That's a issue. We do it mostly after. So we're looking at what happens, let's say 5 to 7 days after 3 cycles. So by then, the acute effects will be gone. So then we've never done that, right? So we never monitor the heart rate during,
It's
and
not the
that I
heart
think will
rate,
be
it's
very
the
very
heart rate
interesting.
variability, which is an indicator of health and, resiliency
Oh no, I
to,
thought you say
yeah.
heart rate.
No, heart rate variability.
Oh, okay. No, no, no. We haven't looked at the variability.
It
No.
would be very interesting, especially based on what Joyce is saying, to look to see how our heart rate variability might be affected, because that's expressing how well the body, the heart, is able to tolerate stress.
Yeah, but that's what I was saying, right? So we've
Yeah,
never measured anything acutely, right? So we always measure it 5 days after. By then, the acute effects have be gone, right? So yeah, so we've never done that.
Well, however, if it did lower your sensitivity and sort of the stress level in your body, it might show up 5 days later, both perhaps in better heart rate variability and lower heart rate, perhaps.
that's
Yeah,
what I was
yeah, yeah.
thinking.
Sure. I mean, I don't know much about heart rate variability, but we
You might
can
want to check it
certainly
out.
look
It
at
might
it.
be a very nice indicator or a good correlation factor to see the long-term effects of this.
Yeah, so heart rate variability refers to monitoring for how long?
Well, they usually do it, they can do it like for a 30-second spell, and it's supposed to be higher because it's sort of reflecting your body having this correlation where your heart rate changes with your breath, with your breathing
Right.
pattern. Yeah,
So
and
for
so
in 30 seconds, they look at how variable it is.
yeah,
Is that the idea? Yeah.
yeah. And
Right. High heart rate
there's also
variability is a good sign of stress tolerance.
Yeah, yeah, yeah.
yeah,
Very
and if it's
interesting.
low, it means you're more stressed. And I think it's sort of correlated with heart rate itself, but it is somewhat different.
Yeah, I think there was a
So the variability it should be based on the respiration
Yeah,
rhythm, or
that's part of it, but they actually do kind of complicated frequency analyses because they'll look at the
huh.
short-term changes, some of which is related to breathing, and then they look at other patterns too. They get into very complex, you know, analyses,
And
spectral analysis.
who's a good scientist that specializes in this?
There are quite a lot of
A
peer-reviewed
ton
papers
of
on
them.
HRV you can check out.
Yeah,
Yeah, and in
yeah,
fact, pretty much most diseases, if you look, you'll find some studies on heart rate variability. It's been very
yeah.
commonly.
I think you in the presentation you mentioned pre-diabetes, and I remember that there came a paper out this year that showed direct link between diabetes and pre-diabetes and cardiovascular disease. I'm not sure about the exact heart rate frequency, but they showed like links. But I would have to look it up. I read it this year, and then
yeah, yeah.
I don't
But
know. It's
since
not
this is the interesting part, it seems like this heart rate variability is linked to potentially some of the inflammatory responses to food, right? So that's a part that I think is very, very interesting. Or maybe not just inflammatory, but maybe also just the type of food you eat and the calories you take in. So yeah. So it'd be
yeah.
definitely worth it because it's so easy to measure, right? And eventually, like you said, there could be apps that do that for you and analyze it for you. So that would be very interesting. Right?
Yeah, since it kind of the diabetes state seemed to have an effect, maybe after also a few days you should see an effect. I guess you would have to monitor what the person's state is and then change the diet, and then maybe, you would have to do it in each person and not just,
Yeah.
you know. Yeah.
Yeah, it's an indicator of stress. But I personally think the resting heart rate is a simpler thing to use and perhaps just as good. And that's just my own view.
Yeah.
Yeah, thank you for that. Denise, Katie, Dr. Shah, do you have a question? Yeah, go ahead.
Katie and Dr. Shaw first, if you please.
Go ahead, Denise.
So, first of all, thank you, Professor Longo, for this amazing presentation. I was curious if you could speak to if there were any observations on the role of apoptosis in this entire process.
Yes, I think so. I mean, of course, we only know from mouse studies, but clearly, for example, in the multiple sclerosis work that we did, apoptosis was high, and so is in cancer. And so yeah, it would make sense that if fasting triggers this cleanup process of damaged cells, that apoptosis will be high in multiple systems, and that's what we see. So yes, and also we had done it. We actually had done this a mix studies where we looked at blood from people that are, we think, have anti-aging genes, and then we took human epithelial cells and we put them in the sort of like the blood that would mimic the fasting response, let's say, right? And then we damaged those cells, and sure enough, the apoptosis went way up. So meaning that by having low IGF-1, the marker that I showed earlier, by having low IGF-1, which is driven down also by fasting, the apoptosis was much more likely to occur. Setting up really a protective measures against cancer. So if you get damaged, much more you get killed much more easily, and that's probably why even just let's say 5 days periodically, if it's used to clean up lots of damaged components, can be very beneficial.
That is certainly what I thought you were going to say. And for those who are not familiar with the term, it just means planned cell death. Thank you so much.
You're welcome.
I can go ahead. So thank you so much, Walter. That was a wonderful talk. And by considering the difference between intermittent fasting and calorie restriction, as well as the duration that you just mentioned, I was just wondering what specific interleukins you ended up with that it can play a role. Also, you just mentioned about the IGF factors, IGF-1 factor. However, we know about the role of the IGF-1 in a post kind of synaptic scaffolding protein, and somehow they have a positive impact. That was one part that I wanted to ask you. Another part that was about the lipid, kind of anti-inflammatory lipid in the brain. And did you ended up with any kind of finding or not?
Yeah, so yeah, IGF-1, I think it's very similar to insulin, right? So insulin is obviously a good factor, but then too much insulin all the time, now you get insulin resistance. And IGF-1 clearly has proliferative effects, effects in memory formation, and lots of positive effects. But we have a ton of IGF-1 all the time, and also it's endocrine versus paracrine, autocrine IGF-1. So we think that by having lots of circulating IGF-1, which is driven up by protein levels and lots of food, now you're setting up all these receptors to become more resistant. And eventually, when you do try to use, let's say, in the brain or elsewhere, the local IGF-1, they may be working less effectively, just as we see for the similar, insulin and insulin receptor couple. And fats, I mean, obviously during fasting, prolonged fasting, you have lots of fatty acids and lots of ketone bodies, including lots of ketone bodies in the brain. And most people don't know that ketone bodies are also generated not only by the liver, but also by the astrocytes in the brain, right? So now we're looking at that, and so there's lots of evidence now that some of these fatty acids and ketone bodies are promoting, stimulating stem cells to activate and start proliferating. So a number of papers coming out and by other groups, and so it'd be interesting to know which fatty acids are specifically involved in improving, in activating stem cell in the brain and elsewhere.
And what kind of pro-inflammatory factor did you just came up with? Any kind of interleukin get involved during your test?
Interleukin, we're seeing a mixed message, and we're starting to see what potentially we call inflammatory regeneration, like the TNF and the different interleukins seem to be, and maybe that was the role of lots of these inflammatory factors, to rebuild, right? And in the conditions where they cannot rebuild, they cause damage, right? But it's an interesting possibility, right? That a lot of these pro-inflammatory factors are actually sort of in an aborted regenerative status, right? They're trying to do something which is not allowed. That's what we saw in our IBD work, and we're starting to see also some of these in our Alzheimer work, where the FMD, some of these factors seem to be elevated and not reduced in the FMD, and we suspect that maybe they're involved in this proliferative regenerative effects.
And what region of the brain had the more high concentration?
I forgot, but there was some of these inflammatory factors that were actually higher, and not lower, right? So in yes, so and I'll have to look at the paper again, but it's in the paper, And I remember we had a long discussion when we published our inflammatory bowel disease paper, because the reviewers were saying, well, you have TNF alpha that is much higher. How do you explain this? And there was one of the interleukins that was much higher. And then we started reading, and we realized that they were both central in the regenerative process of the gut.
Thank you so much. But I mean, bottom line, based upon whatever you mentioned, you refer mostly to the astrocyte, not, for example, concentration of the dendrocyte, right?
The astrocytes. What's your question?
So you refer to the astrocytes, and when I just asked my question specifically about the IGF-1, not about the concentration of the IGF-1 or dendritic cell in relation with the IGF-1.
Yeah, the astrocytes, I just mentioned them because they make ketone bodies, and astrocytes are also elevated in our Alzheimer model, and I think they were reduced by the FMD. But I didn't understand your question still in regards to IGF-1. So what specifically is your question on IGF-1 and astrocytes?
I think I got my answer, and because we don't have that much time, I'm passing the mic to the next person, and thank you so much for your answer.
Sure.
Thank you. Katie, did you have a question? Thank you.
Hi, it's Katie speaking. Thank you so much, Katerina, as always, for putting together such an amazing discussion. And thank you so much, Dr. Longo. Really fascinating research that you're doing. Obviously, really well respected in your field. And just encourage everyone you can also save the papers that are put in the chat. As well as the Google presentation that's at the top.
Okay.
Fascinating research. Thank you so much for being here. I'm sure most of the others on the stage know where I'm going to go with this. As someone I'm a scientist myself, and we know that COVID is producing a lot of inflammation all over the body, including in the brain, and there is evidence of cognitive decline, dysfunction, and Alzheimer's type signals that I'm sure you're familiar with a lot of the literature around that. As someone who contracted COVID and has long COVID as well, many of us have elevated CRP markers. Mine were up for over 18 months. And I certainly found that adjusting my diet, I don't like to call it diet, but the foods that I ate made such a difference, just as Joyce, shared with her experience with her illness as well, with someone who never had food sensitivities before. So I'm just wondering, do you see any potential for, looking into this for COVID patients and how it might help them, particularly when it comes to the degenerative decline? Thank you so much.
Yeah, I think so. COVID, in a sense, is sort of the perfect. In long COVID, is the perfect target for the fasting mimicking diet, right? Because a lot of the effects seem to be related to inflammation, and the toxicity seem to go along with old age and age-related diseases, right? So, yeah, we would love to do it. So far, nobody has approached us to run a trial, but we would love to. If a clinic was busy seeing patients with long COVID, A, we would love to do it, and B, I think I would be very optimistic that we will see improvements, just because so many of the things that may go wrong with COVID are potentially reset by the fasting mimicking diet periods.
Hi, it's Katie. Thank you so much. If you can, or Katerina can put us in touch, myself and Dennis in particular are really involved with the long COVID community. We have patients all over the world that I'm sure would be interested. And I'm also working with different researchers and universities and labs. So I can certainly get involved and, you know, even direct you into the discussions that you should be having with other people.
Sure.
Interestingly, I've been recommended to go on a more keto diet, and as someone who was, you know, plant-based vegetarian for half my life,
Yeah.
yeah, it's
So
interesting.
keto, I mean, you know, my problem with keto is that it may be tricking a little bit the body, or pushing the body in sort of a confused state, you know. So on one side it's a fasting response, on the other side all the calories are there, right? So I think that, like we do a lot of work in cancer, and we're now looking at keto versus the fasting and fasting mimicking diet. And the concern with the keto is that you're not going to get the full you know, shrinking re-expansion effect, right? Because if you have all the calories that you need, there is no reason to shrink. And so if there is no reason to shrink, the white blood cells and lots of other immune cells may not need to undergo a reset. And that's what we see now very, very clearly, we and a number of other labs in mice, but we're starting to see the same evidence in people when we do clinical trial. So big drop in white blood cells, a big drop in neutrophils, but some other cell type actually go up. So yeah, I think that that is definitely an interesting set of studies to do. Yeah.
Yeah, thank you, Katie, for asking. Go ahead. Did you want to follow up? Go ahead, please.
I was just going to say thank you very much, and I hope we can be in touch. That's all. Thank you.
Yeah, sounds good. Thanks.
Yeah, I was thinking about the whole time about Katie, that she would probably like to ask this question. And welcome, Elizabeth. And before the question, Walter, do you have around 3 more minutes or so?
Yeah, that's fine. Yeah.
Okay. Welcome, Elizabeth.
Thanks.
Go ahead.
Is the question about the keto diet more related to advanced glycation end products? I mean, how much fruit can you safely eat in one meal before you raise your advanced glycation end products? And isn't that a major component in inflammation?
Well, advanced glycation end products are accumulated probably slowly, and they do contribute to inflammation, but I don't think they're central for inflammation. And the ketogenic diet, I think that depending on what it is, right? I mean, there's different type of ketogenic diet, but doesn't necessarily have a big effect on average glucose levels. It could have a small effect, but not necessarily a big one. And some ketogenic diets do if they're more extreme, but some don't. So yeah, for advanced glycation end products, you would need to keep glucose levels lower, and I probably would, to do that, I will adopt the longevity diet plus the fasting mimicking diet, and both of those were clearly shown to have long-term effects on glycemia, insulin, but also leptin. So yeah, that's very clear for both the longevity diet and the fasting mimicking diet. For the ketogenic diet, I think is much less clear. And again, it's not just about forming the advanced glycation end products, but it's also about getting rid of them, right? So if you don't have a shrinking opportunity, a reset opportunity with the ketogenic diet, maybe the program is going to let lots of these damage components continue to be around, right? So, I mean, yeah, of course, we don't know everything about the ketogenic diet and what it can do, but certainly those are some of the limitations that we see. And not surprisingly, for example, with cancer, with the ketogenic diet, we see some cancers that are killed by the ketogenic diet and some cancers that are helped by the ketogenic diet, right? So depending on the type of cancer cells, whether it can use fatty acids and ketone bodies, or whether it's killed by fatty acids and ketone bodies.
Yeah, thank you so much for the questions and for your answers, Walter, and this wonderful presentation and taking this time for discussing this. Um, let me know if it's okay to write introduction emails, and then for Joyce and Katie, and then
Sure.
yeah, and then we can you guys can go
We can
ahead.
take it from there. Yeah.
Yeah. And yeah, this was such an interesting discussion. Thank you so much,
Oh, you're
everyone.
very welcome.
Yeah, thank you, Walter. I know it
Okay.
was it was a hassle to get this to work, but I don't know. I thought it was a really interesting discussion. So thank you. We
Oh,
really
thanks. Thanks.
I would
Okay.
say, I was just going to say, you can find Professor Longo interviewed often on podcasts, so you can hear more from him. I want to look for his latest one because I just love hearing all his insights. Anyway, thanks.
Oh, thanks. Thank you very much. Yeah.
Yeah, wonderful. Yeah, I shared your website also in the chat. Please, everyone, check it out, and the company website, and yeah, the paper.
Yeah.
So,
In my foundation, right? So there's a foundation clinic in Los Angeles. If anybody's interested, they also do telemedicine. So they, they try to help as many people as possible, whether they can afford it or not. Yeah.
oh wow, that's wonderful. Is everything maybe on the Wikipedia altogether?
I'm not sure. I haven't checked the Wikipedia, but yeah, the foundation is called Create Cures, and that's in Los Angeles, and that's easy to find. CreateCures.org. Yeah.
Great, wonderful. Yeah, so we really appreciate. You must be very busy, so we will let you get back
Yeah.
to
Sounds
your
good.
life.
Okay. Thanks a
Okay,
lot.
bye. Thank
Bye.
you so
Bye. Bye.
much. Bye.
Bye.
Yeah, and I'll make sure to write an email, and we have another room tomorrow. If people are interested, we'll be with Dr. Butson, and he will talk about his consciousness model as a memory system. Um, and then we'll have next week. I'm going to be traveling, so we only have two rooms. On Wednesday with Dr. Young about a 3D camera that learned like a really interesting 3D camera, new hardware that uses some learning to like over time become better. It's a really cool new technology. And then Dr. Han, he will talk about psychopathology, DNA methylation, and he made an index time to death based on the methylation data he collected. So yeah, I think it will be really interesting. So I hope to hear you all back soon. And thank you also, Dr. Roshanak. I know it's in the middle of the night for you, and you still came. So I really appreciate that. And everyone, thank you.
Thank you, Katarina. This has been great.
Wonderful. Okay, I'll close the room in 3, 2, 1. Bye, everyone. Thank you.
Thank
Bye. Thank
you.
you.